Hi and welcome, amazing people. In this video, we'll leverage the repository design pattern to make our app more flexible when it comes to choosing and managing storage solutions. So let's just get started. Under the base shared folder, we have a repository subfolder. Here we will create a new file from template, Swift file. Let's call this journal entries repository. Create. And here our main goal is to create an interface, or better said, a protocol in Swift. This protocol will serve as a blueprint, defining the structure and requirements for each specific implementation of a repository. So let's type protocol, journal entries repository. Now let's think the main attributes or the main functionalities that a repository must have. Let's add a comment here, and first one should be a create. Then we need retrieve or get or fetch, whatever. One journal entry. Usually this is based on an ID. Then we're gonna need a retrieve or fetch all journal entries. Then we're gonna need an update. An update usually has an ID because we need to know what journal entry should we update and the data to be updated with. And last but not least, we need a delete. These are the core operations our app will rely on. The beauty of using a protocol right here is that every repository solution, whether it's in-memory, local, or remote, will be required to implement these methods or functions, ensuring consistency across different implementations. So let's just move these comments above and let's start writing them down. First one is gonna be create. It's gonna need a journal entry of type journal entry. It's gonna be a sync and throws in case it fails. The next one should be retrieve. Function retrieve for a specific ID of type string. It's a sync, it can throw, and if everything is okay, it should be returning a journal entry. The next one is function retrieve all. It's an async function and it throws and returns an array of journal entries. Next one is gonna be function update for a specific ID again, type string. With, we need the data that we need to update the found journal entry. So with to be updated journal entry of type journal entry. Sync and it throws. Last but not least, the delete function. We need to delete based on a specific ID again. It's an async function and it can throw. Now we can delete these comments right here and everything is compact and clean and prepared for implementation. And now the first step that I usually like to take is implementing an in-memory data storage solution. It's fast and works similarly to the mock data helper enum we've been using so far. However, the key difference is that we'll now use the mock data within our repository instead of directly in our view or view model. So for that, let's create another file under the repository folder right here. New file from template, Swift file, and let's call this in-memory journal entries repository. Create. And here, instead of using a class like we usually have, we will create an actor. So actor in memory journal entries repository, which is gonna implement our repository protocol. So journal entries repository. Now it's gonna complain because it has some missing functions to implement. All we have to do is click fix here and just check this out. We have all the functions that we just created on our protocol right here ready to be implemented. So in our case, we're gonna use in memory. Basically, we're gonna use an array right here in this actor that is gonna be updated based on the calls that are done from outside to these methods. But before implementing, you might wonder, why did we use an actor here? Well, an actor in Swift, especially for a repository right here, is a good idea because actors are designed to handle data safely in concurrent environments. Unlike classes, actors ensure that all access to their immutable state is serialized, preventing race conditions and data corruptions. It's really important to know that actors in Swift significantly reduce the likelihood of data races. They are not 100% immune to data races like I've heard in many posts. Data races can occur in an actor too, but it helps us reduce that percentage that data race would occur. Let's go ahead and create that array. So it's going to be private var entries, type journal entry, and the default value is going to be our preview mock dot view journal entries. We have an error here, so remove that brackets. Great, so for test purposes, our default array is always going to have some data in it. Now let's implement the create function. All we need to do for the create is say entries.append the new journal entry. And this will simulate a save for our in-memory data storage solution. really easy, really fast to test our UI and everything else. The next one is retrieve. So for the retrieve, we should do a return entries.first, first where, $0.0.id equals ID. This first is a higher order function that iterates over all our entries, and when it finds the first one that has an ID exactly as the ID that we just passed to this function, it will return that element. So it's really a compact and clean way to find that specific entry, avoiding using for or while loops. Now we can see that we still have an error here. The first higher order function returns an optional, and here we return a non-optional. So let's fix that. First of all, let's remove this return and say let entry equals. And now let's make sure that we have an entry and it's not nil. We can do this with the guard let entry else. And on the else block, we need to return something or throw. But because we are good developers, we won't return anything. We're just gonna throw, letting the user know that an error occurred. That specific journal entry was not found. And for that, we need to create an error. So here, let's create repository error of type error, and the first case that we'll need is case not found. And now this retrieve is gonna throw a repository error. Should also put it in the protocol. And now we can just throw here not found. After that, we can create a do catch block. We can simulate a delay. So wait task.delay.sleep actually nanoseconds 1, and I'm gonna put 1 million here. This is a second, and after that delay, we're gonna return that entry. If something bad happens here, we're just gonna throw unknown error. And our function implementation is done. Let's continue with the retrieve all. This is gonna be a simple function to implement. We're just gonna return all the entries. And of course, if we want to simulate a delay, we can just say do catch, try wait task.sleep, let's say 1 second, and then return the entries. Of course, we can check if the entries is empty, otherwise we should throw an error. So guard entries.is empty, else. So we should add a not here. If this is empty, we should throw an error. And for that, we should create a new error case called case empty data and throw it here. So we should specify the throw here and also in the repository for the retrieve all, say that, and also here and also here. We are just gonna throw repository error dot empty data. Now on the catch block, we can see that we can't just throw unknown, because if this entries array is empty, it's gonna throw an empty data error. And we want to handle that error higher on the call tree. So for that, we have to intercept it somehow. We can write catch repository error.empty data, just gonna throw that error. And for the unknown case, we were just gonna throw unknown. And now when I look to it, we should modify this function too. So first of all, we need a delay. Then we need this filtering. If we can find the entry, just return the not found error. And on the catch block, intercept that not found error, throw it again. And then for the unknown case, just throw unknown. This is way better. Now let's go to the delete function because it's shorter. So we need to modify this to throw a repository error. Again, we should copy this delay task. Let's make it a bit shorter. So maybe half a second. Wrap this in a do catch block again. Now we have to find the entry with the ID given here in our array here. So for that, we're gonna use again a high order function called first index where. So guard let index equals entries dot first index where the ID is equal to our given ID in this function. Else throw repository error dot not found. After that, it's as simple as just removing an item from an array. So entries dot remove at the index that we just found earlier. Here we have an error. It should have been first index, not first. Everything should work fine now. On the catch block again, intercept this not found error and throw it. And for the unknown case, throw dot unknown. And in order to be more specific for this delete operation, instead of throwing a not found, we could create a new error called case delete failed. There we go, we have a delete method implemented. Let's continue with the update method. So again, let's just copy this delay simulation, put it in a do catch block. In order to update an entry, we need to find it first. So just copy these 3 lines and paste them right here. Instead of delete failed, we should create another case called update failed. Paste it here. Now, after we found the index that we need to update, we have to find the entry corresponding to that index. And for that, let's just type fetched entry equals entries brackets index. This gives us the object. Now what we want to do is to update this object that we just found with the object that is given us by whomever called this update. So fetch entry should be replaced with to be updated journal entry. And for that we need logic. If we go to the journal entry, we consider that an update should appear when the content is different than what we found in our database, also, or when a well-being rating is different than what we found in our database. So to translate that into code, we can type if fetched entry dot content is different than the to be updated journal entry dot content, or the fetched entry dot well-being rating is different than the to be updated journal entry dot well-being rating. In that case, an update operation is valid and can happen. So let's just replace it. Entries.index equals to be updated journal entry. Let's intercept that error from above and throw it. Of course, for that we need to copy this here. And for the unknown, throw dot unknown. And that's about it. If this condition is not met, nothing should happen. The update condition is not valid, hence the database content will remain unchanged. And the last thing we should do is update this save method, so it should also throw a repository error. If it's not updated in the protocol, we should update it here too. Now let's simulate a half-second delay, put it in a do catch, create a new error called save failed, and just throw it here. This one is probably not mandatory for this in-memory solution because this append will always succeed, but we just made sure that maybe if this task.sleep is cancelled or something, we have a throw in place. Now if you build the project, you might see that we have an error. If you go back to our journal entries repository protocol, you see that we pasted the error type in the wrong place. Just place it here and hit Command B, and everything should work just fine. And that's it. We've successfully implemented a robust repository design pattern using Swift protocols. Along the way, we created an in-memory data storage repository, which not only helps us with debugging, but also speeds up the UI development. Plus, we set up a solid architectural foundation for future enhancements. So great job to you for that. In the next video, we'll integrate the in-memory repository into our own view model right here, fully decoupling the data population step from this class. If you enjoyed the content so far, please like and subscribe to stay updated. Until then, happy scribbling!